In the field of geology, observation is the main way we do our research. This may be limited by our human ability to have error. When it comes to doing work in the field, we may be resorted to methods that are limited in scope, such as trying to deduce features that we cannot see with the naked eye, such as crystal alignment, joint intensity, striations, and fabric strengths. To the human eye, we can look at these details, but have our observations be subjective. In its place, we need something more objective and universal in use. With the advent of modern technology, we have that ability via the StraboTools app. StraboTools is a geologic app mainly for iOS devices used that can be used in to image in the field rock outcrops, or it can upload images taken from thin sections or aerial observations of outcrops. For the particular study, this study, we have used StraboTools to look at cores drilled from the IODP Expedition 350 mission, which recovered 1,800-meter thick drill cores of volcaniclastic sediments from the Izu Bonin Rear Arc in Japan. These cores contained muds and volcanic ashes that serve as a valuable record to study structural fabrics and compaction gradients as they relate to lithification, diagenesis, and climate processes in the region. StraboTools is able to give us an advantage by looking at details that are normally not easy to quantify, such as striation as well as thickness and strength and weakness within the material. Using StraboTools is quite easy. For example, we can look in figure A. If you take a scan of the QR code, you can see how it's a very big segment of a 1.5 meter section of the 1,800-meter core. These sections have been taken with a high-resolution camera to account for every detail. In order for them to be used in the app, they had to be broken up into smaller 10-centimeter sections, as you can see in figure B. This was done using an Android photo editor, and the images were previously taken from a shared Google Drive. The sections were re-uploaded to the Google Drive, where they were then accessed on the iPad. Reason being that we didn't do all the editing on the iPad is because its photo editor is very tricky. So it was much easier to use a cell phone instead and just transfer them over the internet. Once we uploaded them to the StraboTools app, it was able to give us several measurements, as you can see in figure C. We have an ellipse with a circle in the middle that delineates features such as in figure C, we see an air pocket entrained in the mud. This can easily be identified by a human eye, but it takes into account smaller details that we may not be able to see. If you look closer into it, you may be able to identify some markers of striations, and striations being very thin lines and patterns within the sediment. Once these images, each image was uploaded to StraboTools, they will later be used in data analysis. Now, when it comes to the StraboTools app being so sensitive, it can take images of features that may not be important to the study, such as glare from the light source bouncing off the water in the mud, or small shadows that may be present. This will be taken into account along with data from initial observations made in the previous study by Kralzik et al. From here, our data will be used to derive compaction gradients that will help us understand the lithification and diagenesis processes within this region. This is an area of study that has not completely been defined, as we know what happens, but not why and how it happens when it comes to volcaniclastic sediments turning into rock. If you have any questions, please post them in the comments, and thank you.